Yo, what's up guys? Welcome back. In last video we have learned somewhat about operations in Python. What we have learned, an operation is simply a symbol that tells Python to perform a specific operation. For example, addition. Addition is used to add and subtraction is used to subtract any value, or multiplication it will multiply, and comparison double equals to it will compare the both variables we have taken, and logical operations. And mathematical operations that we have no addition, subtraction, multiplication, division, float division, remainder, and power. These are the operations we have seen last time, and until we have seen assignment operators, comparison operators, and logical operators. Now we are further going into next operator known as identity operator operators. Okay, let's make it down. Identity operator is an operator which checks whether two variables refer to the same object in memory. Let's take an list 1 comma 2 and y with the another list 1 comma 2, and let's take z is equals to x, and let's see checks whether two variables refer to the same object in memory, not just whether they're equals or not. Here we can see x equals to 1 comma 2 and y is also equals to 1 comma 2, but here z is equals to x. So when we am performing print x is z, it's seeing the same memory, not only the value. If x is y, it will print false because there are two different memories allocated for them. X has one type of memory and Z has another type of memory, so it gives false. And there is another known as not operator, like print X is not Y. Let's print it out, and it's true. Of course, X is not Y, so it prints me true. And this is the identical operator in in Python. It helps us a lot because to check whether the variables have same memory or the same data set we have provided. And let's further go to membership operator, and let's try to see what operator is. Membership operator is an operator which is mainly used in dictionaries to check whether the variable exists in dictionary or not. Like for example, let's take in dictionary apple and bananas and mango. And let's check whether apple it was there in fruits or not. And let's copy and paste, and let's change the name with apple into oranges, and check whether the apple exists in fruits. Of course it exists, so it gives me true, and orange doesn't exist in fruits, so it doesn't gives me true. Okay, apple indexing is at 0 and orange is in fruits. No, it wasn't there, so it gives me false. These are the membership operators which are used to identify whether it exists in the dictionary or not. And in here, if it even changes a capital A to small a, it gives me smalls, because for Python capital A and small a are two different values. It is a highly case sensitive false even if we change a capital letter into small letter. So this is the membership and operators in Python. And let's jump into another important operators known as bitwise operators. Until now, the operators were learned work on normal decimal numbers. Besides operators, bitwise operators are different. They works directly on the binary zeros and ones representing the number. Here, the bitwise operators are the operators which works on bitwise, like bitwise. For example, a equals to 5 and b equals to 3. And let's print the bitwise pin A, and let's print it B, print bin B. Let's run the code first. See, we can see the bitwise operator. So the bitwise value of 5 is 10101 and bitwise operator of B is 11. These are the bitwise of binary code of 5 of variable A is 101 and the binary code of B is 11. These are the binary codes of binary codes for A and B, and this is one of the operator, and we are going and add a leading zero to make them the same length. It will just add, so it does the fucking thing. Okay. So here starts this. So these are the bitwise. It shows the second like binary code of here the function. Here the keyword bin shows the binary code of the two variables A and B. And let's jump into the some good and let's jump into the bitwise operators from starting from now. One is and operator, and which is symbolized as this, and let's check whether if it's and let's check whether what it does. A and B, let's print it out. Here we can get 1 because bitwise operator is operator which gives us the value false. Let's do one thing. Let's keep the 101. Let's write their binary code here and 011, and let's and operator represents multiplication in Python for binary code for binary. So 1 into 1 is 1, and 1 into 0 is 0, and 1 into 0 into 1 is also 0. So the output will be 1 because 1 into 1 is 1, and the output will be like 001. So it to save the memory, it will give us 1. And just think like it returns 1 only if both bits are 1. And let's check another operator known as or operator, which is symbolized by this and represents addition in Python, and it will show the or operator. Or returns 1 only when bits are different. And let's print it out, and we can see it will print us 1 and 7. And let's go further. The next operator known as not operator. Or operator is an operator where it will just flips every bitwise operator. So NOR operator is an operator which is like it will change every secondary in every binary code of a number. Let's check an example and let's clear this out. So basically we have -6. Let's print the bin of my print bin of 5, and whether if we given the output it will gives us 101, and basically it will changes every value and it takes nearly 7. So not operator, whenever we are performing a not operator, just think like If we use a bitwise like binary operation to it, it will gives us output in this format, like 1 not 1 is the main thing we should check. But whenever we are performing a not operator for this number, just think we should take an 8 digits number, like 0 0 0 0 0 5 zeros 1 not 1. So it will change every value into 1 1 1 1 1 0 1 0. It will literally reverse this all. In place of 1 it will give 0, in place of 0 it will give us 1. So this if I want to add that number, we will get -6 as an answer. It's a not operator for it. And if we want a formula for, and we had a formula for this known as not x is equals to minus of x plus 1. So this is the normal, so this is the formula for so this is the formula here. And let's go further to the right shift and left shift. Right shift and left shift are the operations in Python where they perform. Left shift means it will multiply the number by 2, and right shift means it will divides the number by 2. For positive number, ignores any remainder. If you given print 20 right shift 2, it will give us 5. So these are the operations, bitwise operations in Python, and these are widely used to operate operating systems, embedded systems, and networking, graphics, programming, encrypting, and permission management, because they are fast and memory efficient. And these are the bitwise operators we have learned so far. And let's go further. And next we are learning about, and let's learn about operator precedence. Operator precedence is just like, let's take a result variable is equals to 10 plus 5, and it should be multiplied by 2, and just print the result. And let's print the result. Okay, just clear this out so that we will get a clear output for this. So in this way, so in the output we are getting 20, because Python, every time if you want to calculate a equation or anything, it will start as BODMAS. It will start from BODMAS rule. So let's write it, BODMAS. So BODMAS rule will check whether the given result. So if you want to perform this operation, it will check BODMAS brackets of division, multiplication, addition, and subtraction. So it will first multiply and then add. So 5 into 2 is 10, 10 plus 10 is 20. And let's take another result is equals to 10 plus 5 and multiplied by 2. And let's print the result. Let's print the result. Let's keep 2 here and let's print it out. And here we are getting 20 because results, because here the bracket comes first, here b comes first, which means bracket, so it will add first. 10 plus 5 is 15, and it is multiplied to 2, it will give me 30. So whenever we are performing anything like any equation or any mathematical terms in Python, let's first check whether BODMAS is applicable or not. And these are the operators in Python. And let's make a mini project, and let's make a mini thing. num1, let's take an int input from the user, and take num2, let's take input, and let's basically make a calculator. It's a basic one, and next time we can update this in next time we can make it more specific, like taking numbers from you, like if he want addition it should print add addition, and if you want subtraction it will separate the number by using condition statements. Let's add num1 plus num2 and let's copy and paste because I'm too lazy. And let's print let's print again. Let's print. So addition, subtraction, multiplication, one is extra, and division. Let's quickly change the values. Let's clear it out. For y negative, and let's multiply it and let's divide it, and let's and in Python, in Python and mainly in VS Code, if you're running any Python which has an input, the code should be run in terminal. Just run in terminal. So let's give an input 3, 4 and let's enter. Let's run the code. Okay. In Python, if you're performing any project or anything which has input in VS Code, and the Python file should be run in terminal. Let's run it and let's give the input number 3 as input 1 as 3 and input 2 as 4. So 4 plus 3 is 7. Okay, it gives us a good answer. So we have built a basic calculator by using operations in Python, and furthermore we can use if else and elif conditions to make it more efficient. Like we can upgrade this. Let's copy this code and let's make a new file known as calculator. So in this file we are going to improve this project to make a good calculator. Like in next case we are taking if else and elif and we are upgrading it, and everything we have learned we are keeping in this calculator, and we will try to upgrade it more. And in next video we will try to do two things. One, we can add bitwise operators, and let's add condition operators, and let's add conditions and let's add conditional statements to it. So that's it for this video, guys. I hope we can upgrade this calculator as much as we can, and we can literally build a good project. So that's it, guys. Thank you very much for watching my video, and next video we will talk about condition statements. Bye bye.